Good news.
Last lecture video of the unit.
Number 7.
That's right.
All done.
7. 7. That's Roman numerals or something. I don't know. That's sign.
American Sign Language.
So last lecture video in the unit, we're going to focus on what's not a voltaic cell.
Yeah. These are, I'm not going to say less important, but how about less common?
Right. The key testable vocabulary and terminology when it comes to electrolytic cells is what is the difference between a voltaic and electrolytic cell?
Right. And that battery is the number one answer.
Mm-hmm. These are non-spontaneous reactions, meaning they must be forced using something. We got to push them along.
Which is that electricity source.
That direct current source, a battery. It's got a positive and negative terminal.
We could plug it right into the wall and get power from the wall if that's what I needed.
In order to make
that would work.
It sure would. Absolutely.
I'm giving it electricity because it's a non-spontaneous reaction.
These type of cells are actually extremely important and useful in industry
because we can make some chemical reactions happen that
wouldn't normally. Yeah.
So you might value what comes out of that.
Right. For example, the electrolysis of copper chloride.
Yeah.
This is copper electroplating. If you've ever had a piece of jewelry like your earring there, I don't know if that's solid gold or if it's plated, but
it's solid just because my ear hasn't turned green.
But it might be plated. I know my wife; she can handle plated jewelry. And so I save a lot of money because I can buy her gold plate instead of solid gold and solid silver.
Nice. And
so for that reason, that's why we would do electroplating. So you got silverware, you want to cover it in gold.
He hasn't done the
silver.
pennies for you. He does have the
machine.
Oh yeah. He has the instrumentation at the mothership that I don't have.
Yeah.
Where you can actually turn the pennies into, what were you calling them?
Silver. Silver. Well, with zinc. Yeah, we silver a penny with zinc using a redox reaction in an electrolytic
But they look
cell.
mad wavy because they're pretty shiny.
Sometimes, yeah. Otherwise,
really
the mix gets messed up, and it's not perfect like it would be.
Sometimes it works out
factory.
Really cool. I've seen them though.
Yes.
Okay.
Ask me to do it.
On to the notes. Electrolytic cells, specifically non-spontaneous reaction that need electricity to go. Right. If you see a battery,
that giveaway.
That's the negative. I didn't show the symbol. Can I do that real quick?
Oh, for a battery?
Yeah. Sometimes you'll see this.
Long, short, long, short, long, short.
If you see that where the voltmeter normally would be,
that means it's a battery source.
That is a
power
symbol
source
for battery.
And that's really garbage because that's a physics terminology that you don't know unless you've taken physics. And even then, the way we teach is physics comes after chemistry.
We're not going to throw it out there a lot, but hey, CYOA, just want to make sure you got it if you see it.
This symbol is an homage to the galvanic pile. Originally, the first batteries.
And that's literally where they get the word pile from.
Yep, P-I-L-E.
Yeah.
And
guess what? These guys flow backwards.
Yeah. The electrons flow backwards. It forces the reaction to go in a certain way because it's non-spontaneous.
Right.
So the battery is the source of electricity to drive the reaction. And that's how you know it's an electrolytic cell, so it's got a battery. You can't use heat to drive these reactions. You can't use catalysts to drive these reactions. You must use electricity because, again, redox is all about electrons.
Yeah. Electrolytic.
Electrons, electrolytic cells.
There are some purposes we use for this. And this whole production of hydrogen and oxygen, well, that's called the electrolysis of water.
Yes.
We've actually learned a lot from this laboratory experiment about moles and other things, but it has some practical purposes too because guess what?
Well,
hydrogen is a fuel source. Hydrogen cars were going to exist for a little while.
Yeah, we discovered that electricity and batteries are actually better.
Yeah, well, and probably more efficient. But guess what? I think we all need oxygen.
Yeah, and those of you who are going to be on the first mission to Mars, please remember the electrolysis of water because when you get to Mars, your rocket's going to be all out of rocket fuel. You're not going to have any hydrogen and oxygen to mix together and shoot back to Earth. You're going to have to make it when you get there.
Yep.
And you're going to have to zap water with electricity.
Here, since you do this so well, I'm going to let you do this.
Electroplating precious metals, so like platinum, gold, all that stuff is mad expensive, and we all want it, but we can't all afford it. How can we get to that point? Well, we take a cheap piece of metal,
and in the shape of a fork,
a spoon, a knife, a piece of jewelry, whatever it may be, your grills, okay? Take a cheap piece of copper, nickel, whatever.
Okay, different density.
Absolutely. You coat it with a relatively thick layer of the precious metal.
So now it's not all precious metal.
It's
making
just
it cheaper.
the surface is precious metal.
Right,
So
and you got to force it.
exactly, like a set of all platinum grills would cost like 30, 40, 50, 60 grand. But if you get some platinum plate, it might be out only $1,000.
Right.
And so you get the same look without all the cost.
Right. And then I think we all have this going on. Hold on, that's my phone ringing.
That's my phone ringing. So whenever you plug your phone into the wall, an electrolytic circuit kicks in and forces your phone to recharge
There you go.
using the electricity and the power from the wall. It's in discharge mode when it's not plugged in, running in a voltaic cell pattern.
And then
It's
it
a spontaneous and
to
it
electrolytic
switches
cell to
to
charge.
recharge overnight.
Isn't that cool?
And so as the anodes and cathodes in your batteries inside here wear out over time, it doesn't hold a charge very well. It starts
You got to
getting pretty
replace the battery or get a new phone.
That's what you got to do.
And batteries in cars wear out same way.
Exactly. If your battery's dying all the time,
And you got to put it on the charger. You can give it some life, but eventually
it's just over.
it won't hold.
Exactly, because all those chemicals inside just get tired out over
Yeah,
time.
they lose power.
Back and forth,
Yeah.
back and forth.
Guess what?
That's all, folks.
We're done.
Thanks. Let's really hit that practice up because
Please.
that is what this unit's about. It's
This-
not necessarily about all the little facts that we dropped on you in these lectures. It's about
Can you assign oxidation numbers? Can you decide where's an oxidation, where's a reduction, and then can we put them all together into a battery?
oh yes,
That's the whole unit.
it is. You did a good job of that in about 5 seconds. The whole unit. You taught the whole unit in 5 seconds.
Boom, go.
All right. See y'all later. Bye. Where's my clicker buttons?